সুমন্ত,
হ্যাঁ স্যার।
এখানে চলে এসো। ওটা
হ্যাঁ
ফিক্সড করতে হবে তো।
হ্যাঁ স্যার, হ্যাঁ স্যার আসছে স্যার। স্ট্রিম হচ্ছে ইউটিউবে।
স্টার্ট হয়ে গেছে।
হ্যাঁ।
ওকে। Good morning to all. So we'll shortly start our session. Professor Asif Iqbal will be joining very soon. He was engaged in some other talk, so we'll start. Maybe it will be 5 minutes more. He will take, and then we will start.
Hello.
Yes, Asif sir.
Hello. Hi.
I could not see.
You cannot see me, right? So the video may be a problem. So that is reason I am not making it one.
No, your
Is it
login is
okay
WebEx 7.
without
Is
the
it you?
video?
Is it you, WebEx 7?
Hello. Can you hear me?
Yeah, we can hear you, but login is Webex 7. Your login ID, I could not see your name. Hello? Hello?
Yes, you cannot hear me?
Yeah, now it's fine. Yeah. So are you ready? Asif sir, are you ready?
Okay, let me connect to the microphone. So it is not getting connected to the system.
Okay.
Hello, now can you hear me?
Yes, we can
Okay,
hear.
now I'm done. So I'm ready now. We can start. Huh?
Okay, please share your screen.
Yeah, yes, I'm doing that.
Yes, sir, we can see your screen. Good morning to
I can.
all. Yeah, we can see.
Okay.
So we can, yeah. So good morning to all. Let me introduce Professor Asif Iqbal. Uh, Dr. Iqbal is currently an associate professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Patna. Prior to joining to IIT Patna, he has worked as postdoctoral research fellow in University of Trento, Italy, and Heidelberg University, Germany. He received his PhD degree in computer science from Department of Computer Science and Engineering, Jadavpur University. His research interests are in the broad area of AI, NLP, machine learning, and many more. Currently, his research focus on information extraction, machine translation, sentiment analysis, emotion analysis, dialogue, and the text mining. He authored or co-authored around 150 papers in the journal like ACM Transactions, Plus One, Knowledge Engineering, and many more. And conferences in the top tier conferences, he has been recognized in top tier conferences like ACL, Calling, ECL, EACL, EMNLP, etc. His research is supported by many industries like Elsevier, Accenture, Samsung, LG Soft, and different private government organizations such as METI, DST, MHRD, CDOT, and many other organizations. So on behalf of the Department of Computer Science and Engineering, I welcome Dr. Asif Iqbal to this event. So sir, over to you.
Okay. So thank you, Professor Vidyut, and thank you for inviting me. And this is my second time to talk. I got the invitations from NIT Rourkela, and last time also I remember that I talked on sentiment analysis. So I tried to make maybe the audience may not be seen that. So I will give the brief I will mainly some state of the art research, okay, and also the research that we have been doing at IIT Patna. So mainly I will focus on how the deep learning methods can be applied for solving different kinds of problem of sentiment analysis. Probably all of you who might be knowing that if you have worked in data mining, natural language processing, or artificial intelligence, that sentiment analysis is a very important topic nowadays. And why it is important, so I'll motivate you throughout the lectures. So this is the outline. I will briefly introduce the sentiment analysis, then I will mainly concentrate on the more recent fine-grained sentiment analysis, which is also known as the aspect-based sentiment analysis. I will discuss about deep learning methods for solving this particular problem, and the very specific problem, like in aspect-based, there is a concept of inter-aspect dependency. Then what will be the aspect specific representations, how the context plays an important role in and how the context can be represented efficiently for determining the polarity values. Then if the time permits, I'll talk about how this problem can be solved in a multilingual and cross-lingual situations, and this is the orientation of opinion mentioned in a piece of text. Now, what is the orientation of opinion? That can be either positive, it can be negative, it can be neutral, sometimes can be also conflicting images. This is the typically how sentiment analysis is defined. Now, why do we need this particular doing the sentiment analysis? Because what others think is always very interesting to know. And this is not new that only nowadays we try to know the other's opinion. So if we go back before the internet era, let's say before 90s or so, or if you talk to your parents, for example, our previous generations, they used to take a lot of decisions not by looking at the contents in the internet or the reviews available in the different platforms. Rather, they used to consult with their parents or their colleagues or their friends or their maybe the neighbors who are experienced in taking a particular service, buying a particular product. Let's say if you go, for example, uh, say a particular car. So at that point in time, they used to discuss it, talk to those people who have experienced in that buying that car or buying that particular televisions. At that point in time, let's say when people used to go to the movie theater for watching the movies, all these decisions they used to take by discussing or taking the opinion of the persons who already uh, have seen that particular movie. But nowadays, if you see that we hardly do that, right? So we want to whether to watch a movie or not. It is not necessary to ask to the people who have already seen that particular movie. If I want to buy a particular car, I can search in the web. There are plenty of reviews available. I can compare between different cars and finally can decide. If you let's say want to study in some foreign universities, in a specific area. So there are a lot of forums available. There are a lot of discussions available in the internet. You will get a lot of information about the particular disciplines, about the particular professors, about the particular research group, about where they are publishing, what is the opinion, who have already graduated, where what they are doing. So all these actually play an important role in making a decisions. So nowadays, we hardly talk to the people who have already studied in the foreign university. You don't do that. Rather, you look into the what people are saying. What is the opinion of the other people about that university? So this plays it. That means nowadays, because of this phenomenal growth in the web, in the internet contents, in the social networking sites, plenty of networking sites are nowadays available. E-commerce sites are available, blogs are available. So where people can write their experience about a product, about a service, about a particular, let's say, institutions, and the others can look into it and can form their, can make a decisions. But now, what is the problem nowadays? We have lot of information, And that information is also, if you have many things before you, then you have many options. Now, how to pick up the best option ever, right? So we have, let's say, we want to buy a product of, let's say, Samsung Galaxy phone, for example. If you want to see, you will get maybe many reviews, maybe 5,000 reviews available, because this is a very popular product. Now, somebody will talk about its, let's say, camera, somebody will talk about its battery, somebody will talk about its, let's say, picture quality, etc., etc. Now, depending upon the requirement, we can look into these informations, and then we can choose whether decide whether to buy that particular phone or not. That decisions we can take depending upon our requirement. Uh, but we don't have time to read all the reviews, right? We cannot just read simply the reviews one after other and then make a decisions. So here there are two scenarios have been shown: the scenario 1 and scenario 2. So you see that in the first scenario there are 1,000 total reviews about a product, and a particular person wants to buy the phone, and he's getting access to the Amazon, and then he has got access to the 1,000 reviews. Now, if there are 850 negative, 100 positive, and 50 neutral, so overall we can say it is negative. In the right scenario, you can say again 480 positive, 420 are negative, and 100 are neutral. Then also we can decide that maybe majority are positive, so overall the sentiment is positive. Now in the left part, let's say if this 1,000 reviews is presented to the user X, let's say, and he reads the reviews one after other, and let's say the 100 positive reviews are appearing at the beginning, okay, and the other reviews, so all are the 100 positive. So you read first review, second, third, fourth, like this, and then after 100 reviews, the person might form his or her opinion that okay, I have read 100, so 100 is a good number. Everybody is saying positive, so this phone is very good. So then he or she will be tempted to buy this particular phone. Okay. However, if the person has the time and if he reads the reviews after the 100 positive reviews, you see that mostly they are negative. That means what the decisions that the person has taken by reading the first 100 top ranked review is not the correct, is not the correct decisions, right? But we don't have time to read all these 1,000 reviews. In the scenario 2, let's say uh, if the person while reading the reviews, he or she has no clue whether these reviews are genuine or they have been written intentionally. Because this is the case that in many situations, the users intentionally write the bad reviews about a product, and sometimes they write very positive reviews intentionally about some product. And this is also the company strategy. Many companies hire their people to promote their own product by writing good reviews, and they demote some other products by writing the bad reviews. This has happened. So the genuinity of the information, that means the reviews that you are looking that are presented before you. So how genuine are those reviews? Taking that decision is also very important. And if you cannot have a way, if you don't have any options to authenticate those reviews, then the decisions that you're taking based on the reviews will be problematic. And that actually, that nowadays this fake information, the misinformation is happening everywhere. So find the information, whether it is fake, whether it is real, and making a decisions is also very important. So on the one side, let's say we have plenty of reviews available. Now, reading them takes a lot of time, lot of efforts. So if you have a system where, let's say, in the scenario 1, if 1,000 reviews are presented to the system, and the system is able to tell you that, okay, out of this 1,000, 850 are negative, 100 are positive, 50 are neutral. So as an end customer, we see that decisions, and then we decide that maybe miserably negative. So the product is not good, fine. So as a customer, I may not be tempted to buy the particular product. But scenario two is more difficult because you have to understand at first whether the information is genuine or not. And then you have to have a system to see how many of them are positive, how many of them are negative, how many of them are neutral. So this is the reason why sentiment analyses are very important, and there are many challenges when you try to solve this particular problem. For example, if you are building a feature-based machine learning systems, you have to have the good set of features. And these features actually are very overlapping in nature. So, for example, in the first case, there are two review sentences. In the first case, you are saying this movie is not good. And in the second sentence, you are saying no movie can be better than this. Now, see that if you do some kind of similarity between these two sentences, they will be highly similar because there are many words are common. Their semantic meanings are also common. But at the lexical level also, let's say good and better are very closer. No, then no and not is closer. Then movie is common. Then this is common. So you see there lexically there are a lot of overlaps between these two sentences. But still their sentiment are different. One is positive, other is negative. Now, and the reviews or the opinions or the people are writing, humans are very creative in it. So they have, so for example, if you follow the writing style of a particular person X and another person Y, you'll find that there will be a lot of differences in their writing styles. Maybe they're writing the same thing, the content is similar, but when they write in a different way. Even a particular person, when they write at different point in time, you will see that they express their contents, they write their contents in many different ways. So how to capture these different styles? That is very important. Okay, if you say that, okay, it is an extremely useless phone, I have wasted my money on this phone, I could have bought iPhone instead of these, all are negative basically, but they have been written in many different. So how to capture this? So that is another thing. Even the different product names, when people write, they write different. Sometimes you write Google phone, sometimes you write G phone. So you have to understand that the Google phone and G phone are similar. This is another NLP problem, which is the co-reference resolutions problem that you have to solve. Now, if you also think that, okay, sentiment analysis is not a very difficult task, I will maintain the dictionary of positive words, negative words, and then based on that, I can decide something. So you can decide, but there will be a lot of ambiguities, and the performance you see that you have to go. For example, here, the same word, let's say the chief, is appearing in two sentences. In the first sentence, however, when it appears, it has a positive sense, but in the second case, it has the negative sense. Why? Because know that if the food is generally cheap, so that means generally it is good, but the service is very cheap is that is a negative sense. So the idea is negative. You know this. In the first case, it is positive. Second case, it is negative. Because when cheap appears with food, it becomes positive. Or service appears with cheap, then it becomes negative. So this context, that means the context of word, okay, plays an important role, and that information is very important to uncover the actual sentiment class of the particular sentence. And above all, as you have seen, the reviews that based on which you are deciding, those may not be genuine many times. Okay. So now, if you look into the sentiment, it can be done in many ways. We'll discuss that. One is the force grade. Social media. It has immense applications in all spheres of these domains. Then traditionally, in the technique wise, mostly the machine learning techniques are heavily solving the sentiment analysis problem. Particularly, the feature engineering based approach was more prominent, but nowadays then it has applications in e-commerce, politics, security, etc. In e-commerce, you can decide, you can compare the two different politics. You can understand the public opinion about a particular political party or politicians. And security is very important because extreme negative sentiment raises a flag about the concerns. It raises a flag to the law and order situations. If you find that the people are extremely negative oriented, they have high negative intensity about a particular event, then that can be a useful evidence to the lawmakers, to the and that actually so particularly in the cross-border terrorism cases, security purposes, national security purposes, sentiment, emotion analysis can play an important role. And there are many sub-problems to this sentiment analysis. Now, some of the sub-problems at first, let's say you have to understand what are the texts on which the sentiment analysis has to be done. It can be, so that means at first you have to distinguish between subjectivity and the objectivity. If you say the sun rises in the east, it does not have any sentiment because it is a factual statement. So when you read the text, or in the text, you'll find that there are uh, portions where you will have the factual statements that do not convey any kind of sentiment or emotions. There will be text that will have some kind of uh, sentiment values. So that means given the text, first you have to distinguish what are the texts that can be potential contents for sentiment analysis and what are the texts that are not potential for sentiment analysis. So this is subjectivity analysis that you have to you can do it, solve it as a classification problem where you have two classes, one is the subjective class, another one is the objective class, and then you can build a subjectivity classifiers. Then thwarting is another interesting problem. Explanation. So see, at the beginning you have a positive tone, but at the end, when you end your let's say statement, then everything turns down to be negative. How to capture it? This particular problem is known as the thwarting problem. The sarcasm. If you say the movie is awesome to put you to sleep. Now, in this case, you can easily see that awesome is a very positive word. Still, in this particular case, it has been told in a negative way. So that means it is a kind of sarcasm. Then humble bragging, for example, if you say that my life is miserable, I have to sign 300 autographs per day. Now, miserable is a negative word. So now in this whole sentence, if you do a dictionary-based sentiment analysis, it will be negative, negative polarity. But this is not correct because the person who is speaking these, he is actually taking pride that he is very popular, and because of that reason, he has to shine or she has to sign 300 autographs. So that means what? So actually, this should not be negative. How to understand this? Then the discourse plays an important role. If you say that movie is classics, then although I don't like this. Okay. So that means this although word is reversing the polarity. Sense plays an important role. To say that sense one is deadly spinner, then the campus has a deadly snake. So in this case, you can see that both are deadly. However, the first case is positive, second one is negative. Nowadays, the intensity also plays an extremely important role in accurate decisions making process. So for example, you can express your opinion. Even if, for example, if you say that after watching the movie, if you ask to your first friend and if you saying that the movie is okay, and the other friend is saying that movie is good, and some other person is saying that movie was awesome. Crickets. Is there any problem? Hello?
No, sir.
Okay, so all are, you can see that all are positive. However, they are positive in different scale, right? So if the person, if I look into the review that the movie is okay, then I may not be tempted to see the movie was good. But if you say that okay, another person has written movie was good, then I form my opinion. Okay, maybe this is a movie that is worth watching. And finally, if you say that movie is awesome, that means now I am more tempted to watch this. So this intensity of sentiment play an extremely important role in deciding whether to buy a product or not to buy, whether to watch a movie or not to watch, whether to vote for a party or not to vote. So for very decision making all over in every sphere of life, the intensity plays an important role. So these are all the sub problems of sentiment, and probably if you are interested in sentiment analysis, you'll find exciting challenges in solving these kind of problems. Now, if you move towards the granularity of sentiments, typically, if you look into the literature of sentiment analysis, you'll find that mostly people have worked on either document level or people have worked more towards the sentence level sentiment. Set documents, and our goal will be to design a sentiment analyzer, and document will be input, and finally you have to say whether the document overall as a positive, negative, or neutral. Or then people started working on sentence level. So now, because in a document consisting of many sentences, few sentences can be positive, few sentences can be negative, some can be neutral, right? So now this sentence level sentiment will give more evidences about the type of that particular document. So people started working on sentence level sentiment. Then also it was found the sentence level even is not sufficient, because in a document if there are three sentences, let's say one is positive, one is negative, another one is neutral, then what will be the overall polarity of the whole document? That can be a problem. Also in a sentence, there can be multiple features are being talked about. So then how to do sentiment analysis for those cases? So if you look into this example, if it is told that its battery is awesome but camera is poor, and if you do the sentence level sentiment analysis, you see that there are two features have been talked about in this report. One feature is battery, the other feature is camera. Now people are saying that the reviewer has saying that battery is very good, awesome, but the camera is poor. So what if you do the sentence level sentiment analysis, what will be the sentiment here? Sentiment will be ultimately 0, because one is positive, another is negative, so plus and minus 1, then it becomes 0, it becomes neutral, which is not correct, right? Because in many situations, people might want to know that, okay, what was the opinion of the reviewer about this particular feature battery? What is the opinion of that particular reviewer about a specific feature camera? So those informations are missing here. How to get that particular information? This is known as the fine-grained sentiment analysis or aspect-based sentiment analysis. So you have two aspect here is the features of the product. So let's say in the restaurant, for example, if you go, so ambience can be a features, then food quality can be a aspect of the particular restaurant. So now if you compare between the sentence level and the aspect level, you see here the aspect level information is giving more evidences to the end users to make their decisions. Okay. So what you want here, we want here that okay, that the a sentiment analyzer systems that should be able to tell that okay, battery is one aspect, camera is another aspect. For battery, there is a positive opinion. For camera, there is a negative. That actually we want to capture from this sentiment analysis. Typically, there are two tasks for this overall aspect-based sentiment analysis. The first task is a in terms of machine learning, you can consider it as a kind of sequence learning task. Sequence learning like part of speech tagging, like entity tagging. So you will given a particular review, and from the review you have to understand what are the features have been talked about in that particular. Let's say in this case, if you say I like the service and the staff but not the food, so it is a restaurant review. So service, staff, and food are the different features that you have to identify first. And this process is known as the aspect term extraction. Then ambience and music, funky, which I enjoy. So ambience and music are the aspect here. The aspect can be also multi-word, like if you say that awesome form factor and great battery life. So now in this case, the form factor and battery life are the multi-words, and that are the aspects here. So after extracting the aspects, you have to identify the polarity. This is the sentiment language. Now, if you know that, okay, service is an aspect, staff is an aspect, food is an aspect, then what is the sentiment with respect to this, given the particular? So for service, you can see it is positive, for the staff, it is positive, food is negative. So now, this is a classification. Right? So given the aspect, you have to identify the polarity class. Sometimes it can be neutral, like in the second example, I did add a assisted drive and a negative. This is a laptop, and neither you are positive nor you are negative. Sometimes it can be conflicting in nature also, like in the last example, the RAM memory is good. So RAM memory is an aspect term, is good, you are positive. But the appearance of this part completely is changing your polarity now. So in one part of the product you are to have positive, but let's say suddenly you are expecting something more from the memory. So you are saying that it's good, but it should have been 8 MB instead of. So it is a kind of conflict in your opinion. So the opinion can be general. Typically, opinion are positive, negative, and neutral, but also sometimes it can be conflicting. So now there are a few other examples. So what we actually want from these, let's say this review is given to you in the leftmost part, and then the first case, let's say speed and design are the aspect, and then both the sentiment are positive. You can see. Then in the second case, tech support is an aspect, negative is the polarity. In the third case, you see that one is conflicting, sushi is conflicting, and place is the positive. So sushi and place are the aspect. In this case, it is difficult because the aspect term is not directly mentioned here. So this is the implicit aspect identification that itself is a challenging task. Because the reviewer has said that it was very expensive for what you get. Now, what is this expensive? You have to know that expensive from your discourse, from your world knowledge, that expensive is related to the price factor. So price is an aspect term here, but nobody is saying that the price is very expensive. We did not tell that, but you have to understand it. How to identify this implicit aspect, that will be very important. Then I enjoy having a products. Now Apple have many products. Right? For which particular product? You have a positive opinion for which particular object of it. So you are saying it's a brand name, but it has many different products. For which product you are referring to? That is not mentioned, right? So these are all the challenges of aspect based. And finally, I close this introductions with this particular example. See that this is a review about a camera. So now if you do a sentence level sentiment analysis, you see that in sentence level sentiment analysis, you get a review something like 3.5 in the scale of 5. Because there are many features have been talked about, some are positive, some are negative. So overall, the average rating will be something around 3.5 maximum. Now, if I a customer and if I let's say I'm very interested about the zoom, I want to buy a camera which is a good zoom. I don't want to pay much, right? Then you see this product is good for me. However, by looking at the sentence level sentiment analysis, if this particular review, this particular rating is presented before me, I will not be able to make my opinion whether I should go for buying this product or not. On the other hand, if another customer, let's say the customer is very interested to buy something which has good battery life, and let's say the display, then that customer is also confused because he is not very much sure. He's saying that okay, the average rating is there, so whether it is worth the buying of the battery or the display, he has no idea. He or she has no idea. So now, if you present the right path to the users, now you see that the customer who is interested in price and zoom or the picture quality, they see okay, for price it is 4.5 out of 5, zoom 5 out of 5, picture quality 4.5 out of 5. So I am a customer, I am interested in these features of the product, so I will definitely buy. But another customer, let's say, who is interested in display and battery, they will definitely not buy it. That information you are not getting from the left. So this shows you, this motivates you probably that why this providing this aspect level features along with the sentiment values are very important in the well-informed decisions making process. Okay. So now going forward, now let's see that how do you, we have understood the sentiment, we have understood the necessity, we have understood the granularity of the sentiment. We have also understood that aspect-based sentiment analysis is very important. Now let us see that how they can be solved. Typically, they can be solved either using the traditional ML or by the deep learning based models. Traditional ML, lot of features you need. You have to identify the features. In deep learning, you don't need the features, right? So you can, without any features, you can solve the, if you have a good representations, and then you can come up with the good classifiers that should be able to solve your problem. But in deep learning, you need a lot of data for training your algorithms. But in case of traditional ML, if you don't have a lot of data, still you can build a model that will finally classify your comments, reviews, or whatever you are giving to the different classes. So this is how the most of the algorithms, either they follow traditional ML or the deep learning model. CNN people have extensively used. I'm not going into details of CNN, but you know that CNN is a good feature extraction algorithm. So this is an example, like let's say if you do the sentence level sentiment analysis for these, and if you say that this movie is very good, so now if you consider a bigram is 2 words at a time, the window size of 2, then the movie is then is very and very good. These are the different bigrams, and all these bigrams will be represented using a pretend word embedding model. Now word embedding will give you the representation of every word. Now the will be represented by some vector, movie will be represented with a vector, and then you are passing two words at a time to a, let's say, a linear classifier. And that will give you a kind of feature representations, the values, okay, or real numbers. So after doing that, you will enter a situation like this. Let's say the movie will be represented as a vector, movie is will be represented as a vector, is very is also represented as a vector, very good is represented as a vector. Now all these vectors you can see that represented features. This basically is the representations for this bigram. This is a vectorial representation for this particular bigram. Now you have to extract the important features out of this. So that is known as the pooling. Now there are many pooling. You know that max pooling you can do, mean pooling you can do, average pooling you can do. In this case, it will be the max pooling. So across every dimension, it will extract the important features, maximum values. So that's the first dimension. If you consider, say, along this dimension, 0.9 is the maximum. So you extract 0.9. Okay. Then second dimension, 0.5 is the maximum. Third dimension, 0.9 is the maximum value. And this one you have again 0.9 is the decimal. So we pull out that important portions and then pass it through a feed-forward neural network, and finally you predict. Now, why this will be positive, why this will not be negative? If you see these pooled feature vector, you see that the first two features, 0.9 and 0.5, they have been extracted from this very good, this particular fiber. Because this dimension 0.9 is highest, we are getting from very good. Along this dimension 0.5 is the highest, we are getting from this. So out of these four features, you can see the first two features are actually derived. Okay? First two features are actually derived from this particular bigrams. So you can say that this particular feature vector, the pooled feature vector, is dominated by the bigram variable. So it will have more weight, and because of that reason, finally the class will be positive. Okay, that is the idea of how CNN is applied for sentiment analysis. So in one of our work in 2016, so we tried to investigate how we can solve the different problems of sentiment analysis, which is the sentence level sentiment analysis, aspect level sentiment analysis, and also we tried to solve it for multiple languages, for Hindi, or English, different benchmark data sets. And we call it as a hybrid deep learning architecture. Why it is hybrid? Because our main motivation was replacing the traditional, what CNN actually does. In CNN, you have the training set, then from the training, you have to represent every word as a vector. You have an input layer. You pass through the input layer. You have a set of hidden layers, and then you have the same operations like, let's for example, the pooling, then filtering, pooling, and then finally you have to do the classification. Typically, the classification is done through a softmax in traditional CN. So whatever representations you are getting from the hidden layers, that actually pass through the softmax, and finally they are classified. But now, what we hypothesize that softmax is comparatively a weak classifier compared to support vector machines. So what we did is that whatever features was learned from the output of these hidden layers were passed through a support vector machine instead of a softmax classifier. Okay? And this support from the support vector machine, we did the classifications. In addition, we also make a tree by developing a feature-based machine learning algorithms. So we extracted different features based on the different lexicons like MPQA work is a lexicons, NRC hashtag is a lexicons that are available in English. So from those lexicons we had used, we have extracted many features, and then we train a support vector machines to build a feature-based model. And also we had utilized a multi-objective feature selection cycle. So why it was important? Because we had came up with a lot of features, so we want to identify that what are the features that are important for sentiment classifications. Okay, so it is a kind of, that means SVM was a classifier. We feed the features, we select the best features using multi-objective optimization based algorithms that optimize more than one objective. Here we have two objectives. One objective is we want to maximize the accuracy of the model, but at the same time we want to reduce the number of features. So we get the optimized features, and these optimized features were combined with the hidden representations of the CNN, and then they are again passed through SV. That we did. So these are all the changes that we had made, and then we did extensive evaluations on Hindi data, on product reviews, Twitter, movie reviews, English, for example, standard data on Seminar 2015, sentence level Twitter, sentiment classification, then aspect level sentiment, aspect sentiment classification, shared tags data set of Seminar 2014, And these resources are also, you can see that we created our own data for Hindi product and movie reviews, and that have been made available from our page. For Hindi, we had used different features like emoticons, punctuations, marks, sentiment. There is a sentiment is Hindi, then semantic orientations features for the movie. These are the different features that we had used for English and Hindi. For English, we had used the Bingley lexicon, MPQ lexicons, and the other features. And finally, we have seen that everywhere if you see that replacing softmax with SVM and concatenating features that we are learning from the CNN along with a feature-based model, when they are combined together, they actually perform well. That have been shown across the different problems of sentiment analysis and across the different languages. Okay. Now we'll focus on how RNN can be used. Okay. Again, I will not go into details of telling you about the RNN, but typically I'm assuming that RNN is a very, very important neural network architecture that has been extensively used for different natural language processing applications, starting from part of speech tagging, name entity tagging, machine translation, image captioning, and also sentiment analysis is not an exception. So typically, how RNN is formulated, if you have the input in the form of and any point of time, and there is recurrent connections between the different units. So this is at different point in time. So let's say at point in time t, the input is xt, okay, and your hidden state is st. Now this st depends on what? This st is nothing but you are getting from the activation functions. Okay, so you see that this activation function in this particular hidden state is computed from the previous hidden state st minus 1 and the current input xt. And this u and w are two matrices that you can learn from the training. Then how this st, the hidden state at this point in time, that is a tan h, you apply a non-linear over this, you make it a non-linear functions. Then the final the output is depending on this hidden state at this point of time, right? So it is st. This is again a matrix. So VSTP you have to learn through the learning of this RNN, and finally this OT. And then final classification, this OT has to be passed through softmax. So this is how, and this happens at every point in time. ST plus 1 will depend on ST and XT plus 1. And then OT plus 1 will depend on ST plus 1. So you can see that the information is passing from one unit to the next unit at a different point of time. And this works as a memory because you can think that it's a kind of a sequential machine behavior, right? Like the recurrent neural network. Now, for part of speech tagging, where every word in the natural language text is assigned a class. For example, whether it is a noun, pronoun, verb, adjective, adverb, or they are different classes. So in this case, you can see that if you are using a recurrent neural network and this is your input, and if you want to do the part of speech tagging, so you do this, there is an input layer. So the word embedding representation has to be passed, and there will be recurrent layer, and there will be recurrent connections from time 0 to time 1, time 2, time 1 to time 2, like this. And from every time, there will be a softness classifier, and that will classify, that will give you the particular class, like thou will be determiner, Joe will be now. Now, if you want to do the sentiment, then you don't need the classes at every point. So what you can do is that the hidden layer, all the informations will pass from one hidden unit to the next hidden unit. So when you at these positions, second positions, it also captures the history of the first position. When you are in the third one, it captures first and second, fourth captures second, third, and first, like this. So finally, you reach to the last unit was from this particular positions, And at this point, the hidden state will capture all the previous history. And then you finally pass that particular feature representations to a software classifier and then decide whether it is positive, negative, or neutral. So that is how it is done in case of recurrent neural network for sentiment classifications. Now let us see that how this recurrent neural network and its variations, like the RNN has some disadvantages because as you are capturing the information, when you are in the last position, let's say at this position, it captures the whole previous history. And now if the input sentence is very longer, let's say there are 15 words, 20 words, so where you are in the last positions, as you are capturing the whole information from the past, so there can be the loss of information. Okay? And this, because ultimately you have to optimize your model, right? So through the back propagations. So there are two issues with the traditional RNN. Probably you know that. One is the exploding gradient. So gradient values will be very large, or it can be the vanishing gradient, it can be very low. How to address those two different problems? Those two different problems can be actually addressed by following the other variations of RNN. That is the long short-term memory and the gated recurrent unit. LSTM has the ability to forget the past depending upon the event. And it knows how much past, how much history has to be known, and how much has to be forgotten. So if it sees that, okay, too much past is not important, then it will completely undo everything and it will only retain the current state information. This was the reason why the LSTM has the ability to capture the long range dependencies. Okay. Now let us see how LSTM can be used for effective sentiment classifications. So one is that let's say the three models will discuss. One is the very traditional LSTM, then target dependent LSTM, then target connection LSTM. So what the traditional LSTM does, let's see this particular example. Its battery is awesome, but camera is poor. Now there are two aspects here. One is the battery, one is the camera. What LSTM does, LSTM will take the input of every word. There will be LSTM unit like RNN, and it will pass the information from one hidden state to the other, and from the last state you will do the classifications. Now whether it is battery or whether it is camera, you don't have any way to decide the representation are same, right? For battery, if your battery is your target, and if you want to find out the sentiment value for this, then also your input representation are same. When your target is camera, then also your input representations are same. But this is not the correct way. What we should do actually to do that, because battery is a different aspect and camera is a different aspect. If we have two different representations for these different target aspects, then the classifications will be better. How do you achieve that? That will be very important. That variation is known as the target dependent long short-term method. Now we'll introduce, they have introduced this target information, and based on the target battery, you will have one representation. Based on the target camera, you will have different representations. For that, there was a forward LSTM, there was a backward LSTM. What happens is that when battery is the target, learn a representation for a part of the sentences by assuming all the left context starting from this. That means left context, if you consider only there is a word eats. So eats battery life you have to learn fast. And when this is for the right LSTM, sequence of LSTM will do what? It will learn this right sequence. The battery is or some bar camera is 4. So if you see this LSTM-L, it is learning only its and battery, this particular representation. This RLSTM is actually learning this whole sequence. When camera is the target, then you see that your left sequence is more longer now. So one set of LSTM is learning the representations of the subsequence of the sentence until the target, and the right one starting from the target, the right one. Now you see the representation that you will get from the first and the representation that you will get from the second, they are different, they are not same, right? And because of that reason, now if you do the classifications compared to the earlier case, now the classification decisions will be better. And how we are doing this? This is shown in the figure, LSTM, all the left context, and then from the right, that means 4, then each, then camera, then BART, then awesome, then each. So you have a HR minus 1 is one representation, HL plus 1 is another representation. So left representation, right representations, they are combined together, and then finally you combine means they are concatenated, and finally you do the software classifications. So I hope you get the idea of target dependent long term. Now this can even be refined, more refined representation if you can get by introducing battery at every point. So when you are learning the representation for each, you let it know that, okay, I want a representation of this first word with respect to battery. I want a representation of this is with respect to battery. I want a representation of awesome with respect to battery. So this is target connections. So in this case, you see the difference. Every time, at every time point, you are letting your network know that your target is battery. And then again, you are following the left and the right. But battery, when you are learning with respect to the battery representations, you are seeing that everywhere the battery is also an input. So how to get that? At first, you get a representation of battery, that is V target. And for every word, you are just concatenate its representation, and then you pass through the list. And then you just traverse from left to right or right to left. So this additional information, when you pass to the LSTM, its hidden state will give you a representation of W1 with respect to this particular target. So this is very important. And after doing this, they had done the experiment with the different modeling, 3 different models, and they have shown the target connection LSTM is actually better. Then the attention comes. Now in attention, you know that attention is a very important concept in deep learning, and it was basically introduced to solve the problem of missing translations, to translate from one language to the other language. And this kind of problem is known as the sequence transformation. You so every problem, in fact, so not only missing translation, but the most of the all the NLP problems you can pose is the sequence transformation problem. That's a part of speech tagging. So you can say that, okay, you give an input, I like mangoes, and generate output like PRP, VBZ, and NLP. This is your sequence. So from one transformation to one input source language text, let's say this is another target sequence you are trying to generate. For this, there is a architecture called encoder and decoder. So encoder will encode your input and decoder will decode it, right? So the encoder can be an LSTM, decoder can be an LSTM or GRU or whatever you want. Okay. Now, in message translation, it is important to when you do this, that if you generate, let's say in this case, from input to the output, when you are at the first point, you are generating this particular word, which of the input word is important, that you have to identify. When you are generating the second word, all the input sequence like Ram eats mango are not prominent. But you have to know that when you are in the second point, you want to generate at that point, out of the 3 words, Ram eats mangoes, mango is very important. That you have to find out. And how can you do that? By following the principle of attention. So attention says that, okay, I want to generate now which is the in the input sequence, what are the terms that I should focus more on compared to the others. And this attention mechanism has been very widely used for solving many problems, and this is known as the encode, attend, and decode paradigms. So I'm not going into much details of this because time will not permit. But how it does, you have to generate a kind of vectors. Let's say Rab eats mangoes. Now, what is means attention? Attention will generate a context vectors at every point. So let's say Ram, the first word you want to generate in the target site. This is your encoder and this is your decoder. How to generate the context vectors? So this 81, 82, 83, 84 are all attention weights. And this attention weight tells that at this point, at time 1, when you are generating the word Ram, at that point, every word in the input will be given some kind of weight. The first word is given 81 weight, second word is given 82 weight, third word is 83, fourth one is a dot, that is 84. Now you see that 81 will have the maximum weight. So it is a kind of context vector of this hidden representation of Ram multiplied by 81, representation of X multiplied by this and this. And then when you move to the second word, again, the context vector will change. This weight value will change. And now you see that is the third word here. So 83 will have the highest weight. So this way you generate the context vector at different point of time. And this context vector, the weight in the context vector will guide you that what are important. In classification also this has been used. And I'm going to discuss that how this attention can be used for sentiment. Let's say again, we'll discuss with this particular example, its battery is awesome and camera is poor. Now your target is battery here, let's say. Then you know that awesome is a important word. But if your target is camera, then poor is an important word. Camera should be more associated with poor in this particular example. By attention, you can capture these informations. Okay. So this particular work, that attention-based LSTM for aspect level sentiment classification, was published in 2016. Okay, it proposes two architectures. Okay. So the architecture is like this. So let's say I will explain from this. It will give you the aspect, a specific representations, target specific representation. At first, you identify what is your target. If let's say in this case, your camera battery is the target. So you get a representation of battery from, let's say, word embedding. Any embedding representation, globe embedding, word to wave, or whatever you had used. Get a representation for that. Okay. This is denoted by VA, the aspect embedding. And as usual, all the other words you represent of the sentence pass it through LSTM. LSTM will give you a hidden representation. Now, on the top of hidden representation, you concatenate. You concatenate that particular aspect information, and then you generate a vector alpha. Right? Why? So now, in this case, you see this alpha is a vector where every H1, H2, H3, Hn will be weighted by these particular factors, okay, with respect to this particular aspect that you are using. If it is a battery, so every word in the sentence will be considered for its significance with respect to this particular target or battery. So we'll generate a attendant vector for that will weight every word with respect to the target, and then you finally classify. That is one thing. The other variation that was done, that rather than appending aspect after the hidden layer representations, you can also do it to the input layer. It is done here. So you see that at the two places it has been done. So what representations you are doing, and also this VA is appended to the input. So when you are giving input to the LSTM, you know your target, get the target representation, you know your word, and with every word you also append there, and then pass through the LSTM. So LSTM will now have the target specific representation, and again you input another the same aspect information and to generate the attention vector. So these are the two tricks they have done. Aspect information now are being used at two places, to the input and also after the hidden. And finally you are applying the attentions, and then finally you are doing the classification. Okay. And then again they do the experiment. This is a very standard data set, Semivel 2014, and they have shown how it is helping. Now, when you talk about the attention, so generally the attention, there is a concept of how to visualize the attention, which is known as the heat maps. In this case, let's say if you read this, that I have to say they have one of the fastest delivery times in the city. We are talking about a restaurant. And if your target, let's say service is your target aspect, and you want to identify the sentiment class. So when service is an aspect here, you see that this service, which words are important here, that you can get to the attention. You see that fastest, delivery, times, these are very important with respect to service. But if your target is food, they see that tasteless word is important, sweet is important, blue is important. These are highlighted. So every word of the input will be assigned a weight depending upon the target. And that you can visualize through the attention weight. And this kind of a deep shadow indicates the delivery is more relevant to service compared to one, compared to half, compared to any other words in this. In this case, food is more related to the tasteless, more related to the sweet compared to the other words. And that will give you the very strong evidence in the sentiment classifications. Okay. Now, also people have used the attention in different ways. So one way is the interactive attention network. Okay. So why interactive is important? Because in case of interactive, if you say, look into these two examples here, the quality is clear cut, but the battery life is too short. Now you see that short is appearing with the target battery life. Battery life is your aspect, and it is negative. But in the second case, you see the short fat noodle spoon relatively deep, some purva. In this case, short is spoon, but sentiment is not negative here. How do you know that? So you can only know that if you know that, okay, given my target battery life, it is more relevant to this particular context short. If you know your short is given to you, if you can identify that what is the target. Now your target is battery life and picture quality. You have to understand the short is more related to the battery life rather than picture quality. That is one decision. On the other way, you have to also understand that if I know my target, then which context is important. So there is a dependency between your target and the context. And if you know the context, then which target is more from target to the context and from the context to the target. Both these relations you have to, if you can capture, then it will be a better decision. So, and this model is known as the interactive attention mechanism. So I will explain from this particular figure. Let's say what is done. So your target is given to you, and the whole context, the whole sentence information is given to you here. Now, target means an aspect. You get the word embedding, pass through the LSTM, you get its representations. Now, let's say it is battery life is the target. Now, what we are trying to do from this, if you pull out the important features from the hidden representations, then in battery life multi-word, the battery is the more dominating term compared to life, right? So that information will be pulled through this. If you are pulling it, so this feature representation will be battery, will be given more weightage. Now it appears in a context. Now from this context, also you pass through the LSTM, you learn the context, and then if you pull out the important features, okay, then you see that we expect that the importance will be the sort, that particular information will be extracted to this. And then you see this pulling, the battery is passed through this attention layer. And now what you are doing with respect to this battery, what is the important context that you are learning from this attention layer? And in this attention layer, what you are doing, you are actually learning that, okay, if the battery life is my target, my context, important context word is 4, then which part is more relevant to this? So that means with respect to the context here, you are refining, you are generating your target presentations, and with respect to the important target word, you are refining your context representations. So both ways, and that actually is known as the interactive attention network. Okay. So again, they have done a lot of experiment and they have shown through visualizations. In this case, let's say, if you see that the piece is phrase, but the variety of piece is nothing out of ordinary. Now, variety of piece, in this case, that op is not a very important word, you see in the term. Variety of piece is a aspect term. However, the variety is an important word and piece is an important word. So that is highlighted more. Now, given this, and if this is the whole context, you have to learn that, okay, if I know variety and piece, then out of all these context word, nothing, ordinary, these are important. But if you know that piece is your target, then maybe phrase is an important word. This piece is also an important word because they are the same word. So you weighting the context with respect to the target, right? This is how the attention visualizes. Then also after doing this RNN, LSTM, attentions, and there are other attention mechanisms also, like for example, at first you get the word level attention, then the sentence level attention. So those are all the hierarchical attention mechanisms have been also tried. And then the memory network has been also used. In memory network, what is done is that it has 4 important components. One is representation, it is a kind of generalization, and there is a final classification. So what is the advantage of doing memory network is that you can consider as if there is a kind of question answering systems. Answers are stored in a database and you are asking a questions, and from the database you have to retrieve the appropriate answer for that. So when this input feature map is nothing but your query, the questions, you represent that, and generalization step, that means in the memory you have all the possible answers stored. So you have to retrieve you have to make it more generalized, and you have to update your memory by the input that you are getting. And to the best possible answers, and then you have to present it to the output. You have to generate the response. So at first you query to the appropriate index, actual memory slot. You find out from the memory slot, you keep the information, and then you respond it. So this is very important architecture. So what we have done in one of our work in 2018, that we try to identify that the aspects are related to each other, and that dependency can be modeled using memory network. For example, if you see the first case, the menu is very limited. I think we counted 4 or 5 entries. Okay. Now you see that menu is an aspect term. So menu is limited is negative. I think we counted 4 or 5 entries. Now, if you say it is 4 or 5 entries, then we are not in the second part. It is not explicitly mentioned the entries for what, which entry. You see that this entries is related to this particular menu, but that is not mentioned here. So that means if you want to know the sentiment of this particular aspect entries, you have to depend on this menu, because here there is no opinion expressed. I think we counted 4 or 4 entries, so there is opinion expressed in this part. But in the first part, the limited, very limited, this is a opinionated expressions. This expresses opinion. But that is related to this menu, not to this entries. So you have to know that this menu aspect and the entries aspect are dependent to each other. And if I know that for menu, the sentiment is negative, then entry will also have the sentiment negative. So this is known as the inter-aspect dependencies for sentiment classification. Similarly, in the second example, you can see that food is usually very good, though I wonder about freshness of raw vegetables. Then in this case, there is, you can see the freshness of raw vegetables. Raw vegetable is your aspect. There is no sentiment mentioned here. But this is an important word. So you are saying that food is good, food is positive, and then this particular word, the discourse word though, is reversing the polarity. That means though I wonder about the freshness of raw vegetables, that means raw vegetables has a negative polarity. That means there is a dependency between the different aspects. When you do the sentiment classification, you have to uncover the relations between the different aspects mentioned in the text. This is important. This finding we solved using a kind of memory method. So I will explain from this. What we have done is that, let's say this is your target aspect. A is denotes the aspect type. And these are all the words in the sentence, word 1, word 2, word 1. And then this aspect and word embedding representation, aspect embedding representation passed through a GRU. And GRU will give a particular representation. The representation with respect to the aspect for every word. And then you apply attention over that. And finally you get a attended vector. What this attended vector represents? This attended vector represents that representation of the whole sentence with respect to this particular aspect. That is what is done. Now, for every aspect in a given sentence, you have to do that. This is the aspect aware sentence representation you have to do. And let's say we are now focusing on this particular target aspect. So now let's say in the sentence, if there are 5 aspects, so you get 5 aspect representation. All are stored into the memory here. All these are the memory. And this is your target now. Okay. Now this target, you pass through a kind of, this is a kind of damage layer. You map it through a nonlinear functions. And then you try to find out, given this query, I have stored all the representations. Which representation is more aligned to this target? So it is kind of retrieving the answer from the memory from your questions. So this is your questions, you can say which is a target. And you are trying to find out from this memory which is more relevant to this. Right? Extract that. Okay? And then there is another layer of GRU here. This is nothing but only to make another abstract representation, but this is not essential. You may also eliminate this. We found that this every aspect of a representation, when passed to the GRU, it gives another refined representation. We have found out that. So then there is an attention block. So you get an attended vectors with respect to each of these target aspects, right? And then you see that this is an input. So this Q dash is an output memory. So with respect to this, we actually find out this beta t. Beta t represents the attended vectors, and from this Q dash, actually we represent again the GRU based representations. Then obviously the output we are generating based on these whatever slots is more similar to this. Based on that, we are outputting that. After outputting, you can see that we get another vectors, and that actually is passed for the classifications. Right? So for sentiment classifications, and this forms a kind of hop. For hop means, for example, given the target aspect, generating this particular qt plus 1 equal to q dash t. That means in the next time, all this memory will be updated based on these habits, basically, that you have extracted with respect to this particular target. So this is how the memory network typically works. So I don't have much time to go into more details, but okay. So this is a very useful algorithms that has been widely used for question answering and also for classifications, and nowadays also these are being used in the generation for the generation paths. Okay. Then we focused on the multilinguality. So maybe this is our own work, because if you are solving the problem of multilingual or cross-lingual sentiment analysis, compared to English, our languages are less resources. We don't have a lot of resources, like we don't have annotated data, we don't have tools, etc. So also, if you train your word embedding representations, you will find that your word embedding representations will not be good, because the data on which it is trained is not enough for finding the good representations. So often, if you see a Hindi word, and if you want to try to find out its representations from a Hindi word embedding vectors, you will often miss that vectorial representation. Now, what to do with that kind of situations? This is known as the out-of-word vocabulary. This out-of-word vocabulary problem is very in particular we have to tackle whenever we want to solve the problem of, let's say, sentiment classification in a multilingual environment. So how can we solve this out-of-word vocabulary problem? By using the cross-lingual embedding, or we can say it is a kind of bilingual embedding. What it does, let's say, look into this particular example, and then I will motivate you. Every language has its own representations. Right? Now, the bilingual embedding will give you the common, you can see that if you considering the Hindi and English, let's say. So, how to find out a common representation of these two different languages? That is what you want to learn using the cross-lingual embedding and the bilingual embedding or the multilingual embeddings. Now, in our case, we wanted to do sentiment classifications in a bilingual situations or multilingual and cross-lingual situations where we have two languages, Hindi, English, and also English and French. So now, if you how to create this bilingual embedding? At first, what we do is that we generate a lot of parallel corpus by collecting the reviews from the Amazon product reviews, and then we translate them into Hindi using our own machine translation system. And in statistical machine translation languages, there is a word aligner tool available, where every source word is aligned to the target. For example, if this is your source sentence, then and this is your target sentence, you decrease. Then let's say WS3 is pani, the word pani. So this or then this WT4 will be the water. This alignment will be given by the statistical machine translation alignment. This will not be 100% correct, but this alignment will get through the machine translations. Now, traditionally, word embedding models are they follow the distribution of semantics. Probably you know that, and the skip-gram model and the continuous bag of words model are the two very popular approaches. If it is a skip-gram model where given a word, you have to predict the context, okay, that where it appears. Let's say WS3 is your source word, and you want to find out that okay, what are the contexts where it appears. Context what you want to do. Let's say we are considering the previous two contexts and right two. Now WS3, the previous two context is WS1, WS2, and this is WS4, WS5. So this becomes your context. Now, typically, if it is a monolingual embedding, then this kind of situations happen. You only concentrate on the source part. Now it is a bilingual embedding, cross-lingual embedding. So you have to focus on the target words. That means when you want to predict its context, you have to see, okay, given this source word, what is the context in the source sentence? What is the context in the target sentence? Now, how to get the target sentence context? Because this word is aligned to this. So now its target, if you look into the previous two words of WT4, it becomes WT3 and WT5, WT6. So you train these recurrent neural network-based language models with these two contextual information taken from the source sentence, source language taken from the target language. And the representation that you will be getting for this, that will be the common representation, the common language space of both the English as well as Hindi. So this is the idea of this bilingual word embedding that we have used here. Now, how it solves the problem of sentiment analysis? Let's look into this example here. So you see that in the training set, we had an alignment of these two, Akshay and Ho. And we know the representations of Akshay, we know the representation of Ho through our bilingual embeddings. This is source bilingual embedding says that the representation of Akshay in the common language space, and this says that the representation of good in the common language space. Now let's say in the training time or testing time, you get a word with the Akshay. Now you look into the word embedding representation for Akshay. You look up the table, you see that okay, Akshay word is not there. So you don't get it, you have a deep learning model. So now it becomes out of what vocabulary, because that is not present. Now, if you do like this, let's say Akshay you translate, you get the word good. And then if you look up, then you see that target representation is available because good was already known to you. Now probably you can understand that even if Akshay is unknown here, you are able to get its representation from this common language space, because when Akshay is translated, it is translated to good for which you know its representations. Now the same representations of good can be used for Akshay here. So that is the advantage of doing this out of word, solving the out of word vocabulary problem. As Hindi is a morphologically rich language, a lot of inflections we add. So let's say combination is another one. So it can be written in many different ways in Hindi, two different ways in Hindi. Now, but if you translate it to English, it has only one word combinations. That actually gives you the representations. So you see that even if one of them is unknown, ultimately you get its representations. So that actually will, now there will be no problem about out of word vocabulary, and you can use it for training your models. We use two models, one is the multilingual and the cross-lingual. In multilingual, training and testing will be done on the same language, where we have done it Hindi and French.
but we have used the bilingual embeddings. In case of cross-lingual, model will be trained on English because English is the resource-rich language, and testing will be done either on Hindi and French. French is not resource poor, but still in terms of sentiment analysis, the availability of the corpus, the sentiment lexicon, French is not so rich. Okay? So we consider French also as a resource poor with respect to the sentiment classification. So now in multilingual setup, you see that we have the data set, we extract the features, we have a LSTM based, we have employed the LSTM based neural network. You look at the particular representation. If you get it is fine, you don't get translate, and then you create your model. So and these are the three different variants in the cross-lingual training and testing scenario are same. Training is every time on English, but in testing time, it can be Hindi or French. Extract the features, get Hindi or let's say French essay, you can translate it, and finally you can get your classes. Okay, so representations through bilingual embedding. If it is not available directly in the embedding of the particular language, and then finally you can do the sentiment classifications. Okay, and these are the three models that we have tried. One is that the features. Hello.
Yeah, okay, fine. Carry on, carry on. Continue.
Okay, so we have this word embedding plus features initially for every word. We pass to the LSTM, and then the two hidden layers, and then output their predictions. The other variation is you get the word embedding, pass it to the LSTM, get the representation of the sentence. All the extra, these features are basically the external features, and these features we have extracted from different lexicons that are combined, and again you do the classification. In the third case, features are passed through LSTM, word embedding are passed through another LSTM, and then there are merging and layers out. So you see, these features are basically not the neural network based feature, but the external features that we want to add to the deep learning based. And we have three different variations, and we have again tested on English to Hindi situations on our own data sets, semi-well data sets, English to French also semi-well data sets, and then we have shown that this multilingual training, cross-lingual embedding actually are very effective for solving the data sparsity problem or the out of word vocabulary problem in case of multilingual and cross-lingual sentiment analysis. And this is a very important idea. Now I'll quickly take another 10 minutes, and then I'll just show you that why multimodality is important. This is one of the work that we had done in 2019, where now so far we have only concentrated only on the text-based system. The input was always text. Now, if the input is not only text, but let's say if you have the audio, if you have the visual information in the form of video and images, then what will happen? Typically, the availability of video, audio, etc. Help tremendously in doing sentiment analysis, particularly let's say in the sarcasm detections. If you say that, okay, this movie is awesome to put me on sleep. Now, if you do the text-based analysis, you are confused. You will be tempted to assign the tag positive. But now let's say when the speaker has spoken this, if that audio is available, and or when he was writing it, when the video is available, from his facial expressions, from his tone in the audio, you can understand the person was actually sarcastic in it. So that means when you do the sentiment analysis or the emotion analysis is another problem that we have not discussed, but emotion analysis expresses the fine-grained, you can say that human's opinion. So in this case, the images, video, audio, etc. will add a lot of evidences to the text. So in sentiment, typically we deal with the negative, neutral, positive.
But in emotion, let's say we can have many variations. We have the Plutchik's wheel of emotions, okay? And Ekman's basic six emotions, if we say it is anger, disgust, fear, happy, sad, and surprise. Now, in this particular work, we have tried to understand that we build a kind of multitask model. Multitask is a kind of, I can say, an end-to-end neural network that will be able to perform more than one task at the same time. So in this case, you can see that negative sentiment, and if you have the anger emotions, disgust emotions, sad emotion, all are related to the negative. Positive, for example, happy will be positive. Surprise can be both. You can be due to negative also, you can be surprised. Due to some positive also, you can be surprised. So we wanted to solve both these problems, sentiment and emotion analysis, and we solved it in multimodal settings, okay, using a end-to-end deep neural network. Okay, idea was to understand the interrelations between the sentiment analysis and the emotion analysis, and exploiting the text, audio, as well as the visual information. Important, already probably you have understood it, but again I would like to show you these two examples. Let's say in the first case, if you say that thanks for putting me on hold, I have all the time in the world. This is your utterance. This is the kind of dialogue. We have used a dialogue, conversations, and utterance is a particular, you can say that statement that you have uttered during the conversation. So this is known as the utterance in the conversation. So in this case, utterance, you can see that the affect is basically the sentiment value. So here the sentiment is negative. And only using text, you will not be able to do scale that. If you have the, let's say, the pitch from the speech, the tone, the intensity, and then how your voice is changing, depending upon that, that information will play an important role to decide that this is a negative sentiment. Or if you have the visual information available, like when you have written this, the eyes movement, gesture, etc., then you will realize that this is the negative sentiment. If you say, okay, I am fine, fine is a positive word, you may say that, okay, it is a positive sentiment. Still, it can be negative. Because maybe you are sad and they say, okay, don't be worried, I am fine. So, but if your visual expression is available, if your audio speech is available, these informations will help you a lot to understand that this particular statement can be a negative. So emotion can be sad. Emotion is sad. You are in sad mood. And then you are saying others, okay, you people should not be worried, I am fine. So this from the text you cannot cover. You cannot uncover all these evidences merely from the text. You need something extra. That is why the multimodal sentiment analysis plays an important role. Now we solve this problem using an end-to-end network. So this is a kind of very complex architecture, but I will just quickly give you an idea. As I mentioned that you worked in a dialogue setting where the conversation is going on between the two different speakers. Let's say I speak to you, you are answering, again I am asking you something, or I am responding to your queries, and this conversation goes on, goes on. Now, in this conversation, you see that the sentiment and emotion will vary a lot. Because when you speak to your friend or to anyone, at the beginning, you might have one kind of sentiment, one kind of emotion, but as you keep on engaging yourself in a very long time conversations with your friend or your colleague, you will find that the sentiment will keep on changing. Yeah, at the beginning, maybe you are very positive. You talk to your student, you are asking, okay, you have given him a task. So you ask, okay, have you done? Then you are discussing. And then you ask, okay, I gave you this task, have you done this? Then you say, no, the student has not done it. Then maybe initially you had a very good conversation, everything was positive, happy. But then once you come to know that he has not listened to you, then maybe well, and then maybe your sentiment can. emotion can be angry or so on. So in conversation, this is very important. So for that, when I am speaking, let's say in a movie also you might have seen. So the context of the dialogue is an context of the dialogue is important. So we had learned this. We call it as a contextual intermodal attention. That means how the context influences in sentiment analysis that we have tried to learn. Input, you can see the text, audio, and video. These are all the GRE basically. And then there will be the attention mechanisms. And then we want to learn the relation between the text and the audio, relation between the audio and video, text and video, etc. And also we try to learn between the different utterances in a particular dialogue. And at the end, you see the same network is able to perform two tasks. Sentiment values also it will give you positive, negative, and also the emotion values also, 6 emotions also it will give. This is how the multimodal works. And this is a very standard data set. So there are 2,229 videos and these many utterances at 1,000 YouTube speakers. And this is the distribution of the data. And it has positive, negative, neutral sentiment, and they are annotated in the intensity range of -3 to +3. -3 denoting that very negative, then +3 is extremely positive. Emotion is also between 0 and 3. Anger, very low. You are not very angry, but +3 you are very angry. Disgust, 0 value of disgust means okay, you are disgusted but not so disgusted. But +3 means you are heavily disgusted. So these intensity values are also given. And then we have done a lot of experiment. We have seen a lot of results. So maybe I can skip this. So this is the last 2 slides, very recent work that we have done, and it has been published in ACL 2020. We had tried to show that not only sentiment and emotion relations, but also when you do the multimodal sarcasm detection. So already I have given you the example how multimodality, the audio and video are useful for sarcasm detection. Now, if you know the sentiment, if you know the emotion value, that can also help in detecting the sarcasm. Again, we had created a kind of multitouch learning framework for multimodal sarcasm, sentiment, and emotion analysis. Okay, because all these 3 problems are related to each other. This is an example. In this case, you can see that the person is saying, "This is so good that I am gonna enjoy it in the balcony. I can enjoy my view whilst I enjoy my day." If you a lot of words, if you do the video processing, okay, of this particular person, from his expressions, you can understand that the person is not very happy with the kind of dessert that is served to him. And that actually you have to capture to do the sarcasm detections. And here the sentiment and emotions values that the person is not happy. He's very disgusted about the quality of dessert that is being served, that you cannot get from the text only. You have to get from the video. Okay. So then again, we propose 2 different models here. One is the one we call as modal attentions, where we try to find the relations between the different sentences across the different modalities, like this one. And also there can be an explicit representation of the emotion, implicit representation of the emotion. In this case, it is explicit because sentiment you are expressing here, this is so good. Or let's say I can enjoy my view whilst I enjoy my dessert. So explicitly you are using some positive words here. So if you look into this explicit marker in the text, then it is positive, and emotion is also happy. but actually implicitly the person is negative, and also the implicit emotion will be disgust that you can uncover from the video one. Okay. Then we had to create our own data also, and the kind of architecture we followed here that is mentioned. We had actually this is our attentions, inter-segment attentions, where a particular modality, let's say audio, video, or text, and a particular utterance, when they are given, they are broken into different smaller fragments. T is the text, audio is the A, V is the video. And then we try to find out the relation between the smaller segments. Let's say the whole audio you have broken into multiple parts. Whole utterances text you have broken into multiple segments. Whole video you have divided into small frames. And then you see that, okay, whether the smaller segments across the modality has any relation or not through the attention mechanism. That is one way. The other way is that intra-segment. There we have, let's say, the audio, video, text, and then this is the audio and this is the video. We combine everything together, okay, like this. And then you try to divide it into small segments. We get this, and then we try to find the attention. So in this case, what we are doing is that we try to find out the relations within the particular segment. We don't see it across the different utterances. Okay. So this is the two methods that we have used. And then again, there are several experiments we did. I am skipping these. And then maybe I can conclude now. So in summary, we have the sentiment analysis. Because various models like LSTM with attentions, memory networks, we have the important you have to encode. We did not cover that, but if you know the position of the aspect term, that also is very important. Interactive attention, we have seen that not only the aspect aware representation, but given the context, if you also find that what is the relevant aspect to the context, so both way attention if you do, that is useful. Memory network can find out the interconnections between the different aspects, and multimodality obviously can be very useful. So nobody has worked anything on intensity prediction in aspect-based sentiment analysis, which is very important. Nobody also has, there is only one work available one aspect-based sentiment analysis in multimodal scenario. The multimodal two work that I have shown you, this is not at the aspect level sentiment analysis. This is in the conversation setting, in the dialogue setting. Okay? And cross-lingual embedding is very important to handle the multilingual cross-lingual scenario. External knowledge, how can we incorporate into the deep neural network? That is also very important. Transfer learning domain adaptations can be easily should be explored for developing the good sentiment analysis. Now there are many applications to the sentiment. Sentiment can be what we are doing at IIT Patna. We are doing many activities like we are doing the role of sentiment emotion in cyber forensic text. Then we are exploring the sentiment and emotion for identifying the hate speech from the social media, to identify the kind of let's say the radicalizations from the social media. We have also done work on sentiment analysis in healthcare, how sentiment analysis can help in the severity prediction of the patients. That is very important. And we have extensively worked on aspect level sentiment analysis. We are exploring since the last 2 years that dialogue is very important, conversation is very important. So how emotion and sentiment analysis can be done in conversations, how multimodality can play an important role, and then multimodal psychological detections. There are several references along with few of our works I have listed here. with that, maybe I can conclude it. Now, if you have any questions, feel free to ask me. So, can have the discussions now. Yeah.
Professor Asif, this is Satya Babu from NIT Rourkela.
Yes, yes.
Yes, sir. Thank you very much for delivering a very good lecture, sir. Probably we'll be disturbing you again next month for another lecture on NLP.
Okay. So I'll talk about the dialogue system at that point of time.
Okay. Actually, madam yesterday talked over dialogue system.
Yes. So yes, what madam will talk, I will talk different topics.
Okay. Okay, participant, do you have any question? Participant?
Sir,
Participant?
I have
Yes.
one question,
Yeah,
sir.
go ahead, Sudhanshu.
Sir, as you said about sentiment analysis for audio, video, and text data, you have done some work. Sir, I have done some work on data analysis for the Bitcoin and data and cryptocurrency
Yes.
data. But sir, maybe my question will be silly question, but I want to know that nowadays news channel is giving two types of news. One for means special able people. Means through expression they are giving the news, and for normal people also.
Yes.
So, sir, for them, those are blind and deaf people. For them, the person who is saying or explaining the news, how you can find the sentiment analysis for them? Sir, only for expression, you can't find sentiment analysis or extraction of data. So, how you can means can you give a small idea about how I can proceed or to do something for them using sentiment analysis?
Oh no, you are saying that only from the expressions, how can you identify, right? So expression, what in our experiment we have seen that visual information is very important. Okay, so I think if you do only the sentiment video, its performance may not be. We have the text, audio, and video all together, but uh, once if you have to know that with different, let's say, sign languages, right? So when the person talks, so if it's a deep and dark people, so they give lot of visual expressions. Now, on the visual expressions, you can do from the gestures, from different facial expressions, you can get the ideas. So you can get to some amount of sentiment analysis, emotion analysis, but I'll obviously it will not be compared to what I explained for the multimodal
Yes.
study. Okay.
Yes, sir, one more thing. Facial expression, I don't think that only the facial expression as data can be there, because means whatever I have read that about deaf and blind students, that their sign language is very different. Even if they are smiling and saying something, it doesn't mean that they are happy.
Yeah, yeah. So in that case, if you have the captions, for example, okay, the sign
Yes, sir.
language translation, for example, okay, that is
Yes, sir.
another work that we are doing. Let's say that if you are putting the sign language, so you have to convert that into the text, for example. That is a really challenging work. Now, yes,
Yes,
that is true. That from the sign language, yes. So, but from the expression gives lot of indications actually. I can, so if the person, even if he is or she is not able to speak up, but his visualization, if he can visualize his expression, that would give lot of evidences. That is true. Okay, I would say like that. However, I did not work exactly on only on the video or sign language, but my intuition says that from our multimodality experiment, we have seen that visual
yes.
is is a very good indicator for emotion and sentiment analysis. Visual expressions.
Okay, sir. Sir, if I will need some suggestion, I will mail you regarding this, as you have done a lot of work on this.
Yes, sure. Sentiment analysis, we have lot of interest, and still we are doing lot of works on sentiment analysis. Yeah,
Yes,
various
sir.
levels.
Thank you so much, sir. Thank you, sir.
Any other questions?
Hello,
Sumanto?
hello, sir. Good afternoon.
Good afternoon.
Sir Sumanto here.
Sumant, yes.
Sir, I want to ask if we take very small sentence, then there we facing a problem of getting the actual sentiment for that statement. Same with the sentence if it has like a paragraph. From the paragraph, the extracting the sentiment is very difficult. So, how to deal with these small sentences or a sentence or a kind of paragraph?
So you're saying that how to deal with the smaller sentences that
Smaller sentences or bigger sentences like a paragraph. Like,
bigger sentences in a paragraph, how to deal with. So
yes, sir.
one is that deal with means you are asking with respect to the aspect-based sentiment analysis or the sentence level or paragraph level sentiment analysis.
Sir, if we go with the aspect base, then it will be very good, sir.
Yes. So if it is a longer sentences, then obviously the phrase level information, the phrase level sentiment analysis, aspect level sentiment analysis will give you a lot of evidences about the overall sentiment. But if
Okay,
it's a
sir.
smaller sentence, I think generally what we have seen that in our other experiment for review sentiment analysis, smaller sentences generally are very good in producing the result, good result. It does not make a lot of mistakes. Okay,
Okay.
smaller
Yes.
sentences you don't have to. Longer
Okay, sir.
sentences only always introduces a lot of ambiguities in classifications.
Okay, sir. So, how code mixes are affecting these sentiment analysis?
Yes, code mixing is the mixing of more than one language, right? So, for example, uh, in code mixing, one challenge is that at first you have to understand the code switching point, right? Where actually
Okay, sir.
your
Yeah.
language is changing. So that is very important. Identifying that,
Yeah.
and you should have a good language model that
Yes, sir.
representations, right? So that is, if you think in terms of deep learning, and how to represent each and every word of the code mix sentence, that will be very difficult, right?
Okay.
So
Okay, sir.
there is recent one is by Microsoft Research. They have released something on code mix language model,
Yes,
but
sir.
still I think there are many things to be done on that.
Okay, sir. Okay, sir. Thank you, sir.
Okay, thank you.
Okay, thank you, sir. Asif, sir.
Okay, thank you for inviting me
Okay,
again.
okay, see you later.
Okay, and okay, let me know about the next month, and then I will see that what we can talk about. Okay, sure.
Okay, okay, okay,
Translation, dialogue, or whatever it is, we will see.
okay, okay.
Is there anyone who is speaking on machine translation in your program?
Yes, yes, Partho Papre from
Oh,
United Center, he
Partho.
spoke.
Okay, Partho is talking about.
He
Okay, so we'll see
told that
next.
today there will be a hands-on session. Let's see how it was. It will be interactive
Okay,
on
okay.
on machine translation.
Okay. So next time we'll see maybe sometime maybe related to dialogue or machine translation. We'll talk
Machine
that.
translation
Okay.
I think prefer. Anyway,
Machine translation
okay,
also. Okay. See you then. Very much again. Thank you.
okay. So
Bye.
thank you, participant. We'll again meet at 2:30. So, madam will deliver talk on text summarization. So, madam is very particular, I think. She will start exactly at 2:30. So, it's fine. So, we conclude this session. Okay, we'll meet again around 2:20 and then madam will start 2:30. Okay, bye. Hello.